Okay. So we have a new skill. I'm introducing you guys to logarithms. Everyone say logarithms.
Logarithms.
I know. I have to say slow at times because it's gonna be like all funky. You have a blank box. Here is your blank box filled in. Okay. Go ahead and fill that in, and then we'll talk about this. You have a blank few spaces on your homework for the team. So in your notes, you have a few blank spots. Fill that in. Boys, take out your notes, fill it in. This is homework number 9. Already too many. Thank you. So write homework number 9 on this so we know when we organize our ginormous homework packet, if it's in order. Okay, so log is a funky thing, okay? Log is short for logarithm. So if you see the word log, it is logarithm. Let me give you guys an introduction to this really quickly. So if I said y equals, so review, okay? Review. If I said y equals 2 to the x, what is the name of this function? Is this a linear? Is this a quadratic? Is it a cubic? Is it a quartic? Is it a rational? Is it an absolute value function? Is it an exponential? Which one is this? We've learned so much. What is the name of this review? How do you know it is exponential? It has a base, and the exponent's a variable. So this is an exponential. And we also learn inverses. How do we find an inverse of a function? We switch the y and the x, right? So would you agree? An inverse of this function is switching x for y and y for x, like this. Is that an inverse? Yeah, look at that. Look how cool that is. Okay. So let me tell you guys about log. Log. It's one log. We use log to rewrite exponential at times. Because sometimes exponential is so difficult to solve, we borrow log or we use log to solve for our variable. Okay? So log and exponential can be rewritten back and forth and is still equivalent. So that's why this is the first one. Ooh. There you go. So this is red. Log base b of a equals x. Okay? So that's how it is read, or this is how you say it. Log base b of a equals x. If and only if this is a true statement of the exponential. If and only if the exponential is base b raised to the x equals to a. So look at the base. What's the base over here? What's your base over here? Your base is b. What is the base in log? It has to also be b. So the base in log is the same base in exponential. These two are equivalent to each other. Okay. Now let's look at over here in the exponential form. If your exponent is an x, Where does that go in the log form? In the log form, where does the exponent go? After, right? As an output. Would you agree? Yes or no? Yeah. And then over here in exponential form, your output now goes right next to the word log. Okay? So if it's a base, it has to be a subscript. Okay? It cannot be on the same line as the word log. It has to be a subscript of it. Okay? So this is what we're going to use to kind of answer all of this today. Examples 1, 2, and 3. Joe, can you help me read the instruction, please?
Write in logarithmic form.
Yeah, that's all I'm asking you to do. Rewrite it in an equivalent logarithmic form. So first, what's the base in example 1? The base is what? 5. How do we write that in logarithmic form knowing the base is 5? What do we start out with? The word log, right? Log. Log 5 or log base 5? Base 5. Remember, the base goes below the word log. It's a subscript. Log base 5 of what? Of 125. Remember, in exponential, if it's an output, it now goes right next to the word log. What does this equal to? 3, because 3 is the exponent. So, like that. What if you write it like this? Log 5 of 125 equals 3. Is that wrong? Oh, yeah. That's totally wrong. Make sure the 5 is the base and is a subscript. Brendan C.
Why is the 5 being 125? Why is the 5 being 125?
5 is B, so that's your base, so that's a subscript. Right? Your x is the exponent. What's your exponent in example 1? 3. So that's why it's now equal to x. Right? And the 125 is technically your A value, or based on the box, it's your A. So that's why it goes right next to the word log. Okay. All right, let's draw 2. What do we start with? Log. Okay, remember, base has to be a subscript. So I'm drawing these dot lines so you know where to put it. Where does it go? Log base what? 49. Of what? Of 7. And if you want parentheses, is that okay as well? Sure. Equals to what? Equals to 1/2. Why don't you try 3 and then ask your shorter partner to check your answer? Because I'm going to call on you to give me, or actually I'm going to hand you this so you can write on here. Make sure you read it as log base too. No, it's okay. You're going to get used to it. At first it's kind of weird. All right, Brandon, write your final answer on example 3. Brandon, right? Yeah, perfect. Good job. So that's how we go forward and backward, okay? Log and exponential. Sometimes easier to solve in log, sometimes easier to solve in exponential. Examples 4, 5, and 6. Can you please help me read the instruction, Grace? Okay, so write in exponential form. Currently, example 4, 5, and 6, what form is it in? Log. Remember, you can go forward and backward. Okay. Oh, how do we write it in exponential form? You go back. How do you start? Base 9. Square. Box it up. Is that true, by the way? Yeah, that's why it's the same. That's why it's equivalent. What's your exponential form for 5? X to the third equals 343. Can I possibly solve for x here? Because it says write it in exponential, solve it if possible. Can I solve x here? How? Ah, okay. So x to the third equals 343 cube root of both sides. Well, 343. Take the third root. What is it? X equals to? What's X? 7. 7 times 7, 21. 21 times 7 is? That's right. Well, it's not 6. All right, 6. You do it. I'll hand you my computer. Once you're done with 6, can you ask your shorter partner to check the answers, please? Here we go. Miss Victoria, please write in your final answer in the box. Oh. Is Miss Tran right?
She's always right.
No, that's Miss Tran right there. Okay, good job. Example 7, 8, 9, and 10. Can you please, Daniel, help me read the instructions for example 7, 8, 9, 10? Well, what do you do? How do you do that? It's in log form. How you, by the way, the word evaluate means what? Solve. Solve, find the answer. Can't use a calculator. You're not going to be able to use one. So now what? Rewrite it, how? What the other way are you talking about?
The exponential.
Yeah, exponential. Well, in exponential, we want to, remember, in exponential, we want it to equal something. On your examples here, it doesn't equal to anything. What do you do? Make it equal something. What is your favorite variable? X. Sounds good. Can we just make it all equal to X? If you want to, can you make it all equal to a butterfly or a bunny or whatever the next favorite character is? Okay. You can make it equal to anything you want. An empty box, if that's what your choice is. Okay? Not 0, because we're trying to solve for these expressions. All right, example 7. Let's start with that one. Currently, it is in log form. It's not as easily to solve in log form at times. So, what's an equivalent expression of this? 3 to the power of x equals, okay. Now we have to evaluate further. We're solving for what variable? X. How do you do it? Make the bases the same. Because if the bases are the same, I can do what? Drop it, right? All right. So, 3. Okay. Well, 81 is not 3, so 3 to the what? Power 4. 3 power 4 equals 3 to the x. What's x? X equals 4. So that whole expression, log base 3 of 81 is 4. Okay, let's do 8. We went in and make it equal to x. Again, what do you do here? Make an exponent. What is the exponent equation? 2 to the power of x equals 1 over 32. What do you do now? 2 as a base. But how do you make 1 over 32? It's a base 2. Yeah, change it to the first step, guys. Can I rewrite this as, oops, why 37? That's weird. 32 to the negative 1. Yeah. So now that's really 2x equals, what's 32 broken down into?
Negative 32.
Nope. 8 and 4. But remember, I want to use base 2. So 2 to the what? 2 to the 5. That's 32. Raise it to power of what? Negative 1. Power to the power, what do you do with the 2 powers there? You times it. So 2 to the negative what? 5. Bases, are they the same? Yes, so x is just simply what? -5. Okay. Example 9. Can you please go ahead and solve that? And then I'll hand you my computer so you can give me the answer. Once you have solved it, I want you to give your paper to your shorter partner so they can check your work. Huh?
Can you zoom in a little more?
Oh, yes, yes, yes.
I think so.
So just do 9. Here we go. Show us your work, okay? So, Miss Maddie, number 9, right there. Is number 9 pretty easy?
Yeah.
How do I erase? How do you erase?
It's up. Turn around like a pencil. Okay.
I did something.
So swipe. And then click on. Whoa, whoa, whoa. There you go. We were on here. No, that's our homework. I lie. We were not on there. Where did it go? That's okay. I'll bring it back up. Oh. No, that's your homework, so that doesn't count. It's thinking. Oh, there you go. So yeah, turn around like a. There you go. Yeah. Okay. Do you agree with Maddie? Perfect. Last one on this set. What do you guys want to do in the last one? Let me pinch it in so I can find the last one. Okay, so let's decide. On the last one, y'all, all eyes on here for a second, because this is more difficult than the rest. Is it a log, boys? Or is it an exponential? It is an exponential. How do you solve this? It's already an exponential. How do you solve this? Because it's already an exponential. What do you do? This is base 4 raised to the power of what? Log base 4 of 11. So this is currently in exponential. Your exponent just happened to be a log. So, yeah, everything is to that, So this is really like 4 to this. This is really technically what this is. Can you guys see what it's writing? Okay, equals x. How do you solve for this? How do you evaluate this? It's currently in exponential form. What do you do? Put in log. If you can't solve it in exponential, put it in log. If you can't solve it in log, put it in exponential. How do you write this in log form? What's the base? 4. So what do you start with? The word log. Base 4 of what? Base 4 of what?
X.
Of x. Because isn't that what the output is? The output's x? Isn't it always going to go right behind the word log? Equal to what? The exponent. The exponent in this case is just what? log base 4 over 11. Now, tell me, can I drop log base 4? Do you have 1 on each side? Yes, just like exponents. It is the same log over the same base. You can drop them. Final answer is x equals 11. Okay. Copy that down. We are going to continue with the next set, because tonight's homework is just a review of the old one. We're going to try to do the first graphing logarithmic functions. So, continuation. Here we go. So for this one, again, we would try to understand it. It's frozen for a little bit, so I'm just waiting for it to not be. There you go, slowly. Okay, so we're moving on, and we're just going to do the first parent function. Skill number 4, graphing logarithmic functions. Example 1, graph the parent function, y equals log base 2 of x, then find all of the characteristics. That's normal. Currently, y equals log base 2 of x is in log form. We don't know how to do that. So what would you do? What would you do if you see log and you can't work it? Rewrite it in? Great. What's the exponential form of y equals log base 2 of x? Exponential form, expo form. What is that? Y equals log base 2 of x. How would you write that in exponential form? 2. No, not 2. 2 to the what? 2 to the what? Power of not 1. Remember, we're trying to write this in exponential form because it's an equivalent. 2 to the what? Y, you're right. Equals to what? X. 2 to the y equals to x. So if you can't solve it in log, you should always do what? Change it to exponential form. Now look at your exponential form for me. What's the input and what's the output here in exponential form? Which one's the input? Which one's the independent? X or Y? Look at the exponential form. Which one's independent? The X depends on what you pick for Y. So Y is your independent, right? So when we make our table, do we pick values for X or do we pick values for Y? For Y. We will start with -2, -1, 0, 1, and 2. Then we're going to plug it in. When y is -2, 2 to the -2 equals to what for x? A fourth. Okay? Don't these values seem very similar to you? Familiar, I should say? Have we done this before? Yeah, we have. Except we did, it's inverse. By the way, if I gave you that in expo form, what's the inverse function of that? 2 to the x equals y. All we're doing is switching x and y. Okay. Let's go back to our log form. Here we go. Expo form. When I pick -2 for y, 2 to the -1 is half. 2 to the 0 is 1. 2 to the 1 is 2. 2 square is 4. Okay, that's the same value that you would get for log. Okay. Let's plot those. But before I plot those, let's discuss something really quickly. Here are our x values. For log, it is the input for logs, okay? Can x ever be 0 for y equals log base 2 of x? No. How do you decide that? Why did you say no? When y is 0, right, x is what? 1. when y is negative value, like if I pick negative 100 for y, is x going to be 0? No. It's going to be a small number, right? But is it ever 0? No. How about when I pick positive 100? Is that going to be 0? No. In mathematics, what do we use? What do we use to graph, to represent something that can never be? Since x can't be 0, an asymptote. We have, students, we now have a vertical asymptote. Because, so in log, it's now a vertical asymptote. Because it's inverse. When we study exponents, what kind of asymptote do we get? A horizontal. So its inverse means that I'm switching x and y for x. And then we're just going to plot the dots. Negative quarter is going to go down to negative 2. Half is a negative 1. 1 is 0. 2, it's 1. 4 is 2. There is the log equation. Okay. Because this is the parent function, h and k will be what? 0 and 0. X-intercept, do we have any? No? Yeah, where?
Uno, 0.
Uno, 0. What's the domain?
All reals.
All reals?
No.
No.
0 and above.
0 and above. Okay. Non-inclusive. 0 to infinity. You can even write x is bigger than 0. Increasing or decreasing? Huh? Increasing. You're right. From where to where? 0 to infinity. That means decreasing is none. For log, do we have a horizontal or vertical asymptote? What about vertical? Because in exponential, we had a horizontal. Vertical at x equals to 0. Rate of change varies until you guys get to math next year. It's definitely a 1-to-1. Do we have either minimum or max? None for both. Let's go and fill out the axes of symmetry. Do we have any? Nope. Y-intercept? No, because we already have an asymptote on the y, so none. What's the range? All reals. Perfect. Okay. This right here, class, is the inverse of your exponential of 2 to the x equals y. Okay. All right, it's a wrap for today. Yes.